Let's now consolidate the knowledge that we got over the last two videos in a nice diagram that brings everything together that we know so far. And everything starts with the person constructor function that we've been developing. Now, this constructor function has a prototype property, which is an object, and inside that object, we defined the calc_h method. And person.prototype itself actually also has a reference back to person, which is the constructor property. So essentially, person.prototype.constructor is going to point back to person itself. Now remember, person.prototype is actually not the prototype of person, but of all the objects that are created through the person function. And speaking of the created objects, let's now actually analyze how an object is created using the new operator and the constructor function. So when we call a function, any function with the new operator, the first thing that is going to happen is that a new empty object is created instantly. Then the this keyword in the function call is set to the newly created object. So inside the function's execution context, this is now the new empty object. And that's why in the function's code, we set the name and birth year properties on the this keyword, because doing so will ultimately set them on the new object. So next comes the magical step. So now the new object is linked to the constructor function's prototype property. So in this case, person.prototype. And this happens internally by adding the __proto property to the new object. So person.prototype is now the new object's prototype, which is denoted in the __proto property of Jonas. So again, _proto always points to an object's prototype. And that is true for all objects in JavaScript. Great. And finally, the new object is automatically returned from the function unless we explicitly return something else. But in a constructor function like person, we usually never do that. Okay, and with this, the result of the new operator and the person constructor function is a new object that we just created programmatically, and that is now stored in the Jonas variable. And this whole process that I just explained is how it works with function constructors and also with ES6 classes, but not with the object.create syntax that we're going to use later. So just keep this in mind once we reach the object.create lectures. But anyway, why does this work this way? And why is this technique so powerful and useful? And to answer that, let's move on to the next line of code. So here we are attempting to call the calc_h function on the Jonas object. However, JavaScript can actually not find the calc_h function directly in the Jonas object, right? It is simply not there. And we already observed this behavior in the last lecture. Remember that? So what happens now in this situation? Well, if a property or a method cannot be found in a certain object, JavaScript will look into its prototype. And there it is. So there is the calc_h function that we were looking for. And so JavaScript will simply use this one. That's how the calc_h function can run correctly and return a result. And the behavior that we just described is what we already called prototypal inheritance or delegation. So the Jonas object inherited the calc_h method from its prototype. Or in other words, it delegated the calc_h functionality to its prototype. Now the beauty of this is that we can create as many person objects as we like, and all of them will then inherit this method. So we can call this calc_h method on all the person objects without the method being directly attached to all the objects themselves. And this is essential for code performance. Just imagine that we had 1,000 objects in the code, and if all of them would have to carry the calc_h function around, then that would certainly impact performance. So instead, they can all simply use the calc_h function from their common prototype. Okay? So that makes sense, right? Now, the fact that Jonas is connected to a prototype and the ability of looking up methods and properties in a prototype is what we call the prototype chain. So the Jonas object and its prototype basically form a prototype chain. But actually, the prototype chain does not end here. So let's understand the prototype chain a bit better by zooming out and looking at the whole picture. So here is the diagram that we already had with the person function constructor and its prototype property, and the Jonas object linked to its prototype via the _proto property. So nothing new yet. But now let's remember that person.prototype itself is also an object. And all objects in JavaScript have a prototype, right? Therefore, person.prototype itself must also have a prototype. And the prototype of person.prototype is object.prototype. Why is that? Well, person.prototype is just a simple object, which means that it has been built by the built-in object constructor function. And this is actually the function that is called behind the scenes whenever we create an object literal. So just an object simply with curly braces. So essentially the curly braces are just like a shortcut to writing new object. Okay? But anyway, what matters here is that person.prototype itself needs to have a prototype. And since it has been created by the object constructor function, its prototype is going to be object.prototype. It's the same logic as with the Jonas object. So since Jonas has been built by person, person.prototype is the prototype of Jonas. All right? Now, this entire series of links between the objects is what is called the prototype chain. And object.prototype is usually the top of the prototype chain, which means that its prototype is null. So its _proto property will simply point to null, which then marks the end of the prototype chain. So in a certain way, the prototype chain is very similar to the scope chain, but with prototypes. So in the scope chain, whenever JavaScript can't find a certain variable in a certain scope, it looks up into the next scope in the scope chain and tries to find the variable there. On the other hand, in the prototype chain, whenever JavaScript can find a certain property or method in a certain object, it's gonna look up into the next prototype in the prototype chain and see if it can find it there. Okay? So again, the prototype chain is pretty similar to the scope chain, but instead of working with scopes, it works with properties and methods in objects. All right? And now let's actually see another example of a method lookup. To do that, we call the hasOwnProperty method on the Jonas object. So just like in the previous slide, JavaScript is going to start by trying to find the called method on the object itself. But of course, it can't find the hasOwnProperty method on Jonas. So according to how the prototype chain works, it will then look into its prototype, which is person.prototype. Now, we didn't define any hasOwnProperty method there either, and so JavaScript is not going to find it there. And so, therefore, it will move up even further in the prototype chain and now look into object.prototype. And object.prototype does actually contain a bunch of built-in methods, and hasOwnProperty is one of them. Great! So JavaScript can then take this one and run it on the Jonas object as if hasOwnProperty had been defined directly on Jonas. And remember, the method has not been copied to the Jonas object. Instead, it simply inherited the method from object.prototype through the prototype chain. Okay, and that's actually it. That's all I have to tell you at this point. So this is, in a nutshell, the magic of prototypes and the prototype chain. And this will actually become even more interesting and useful once we add inheritance between two different kinds of objects, or two different classes, so to say. For example, having a student class inherit from a person class, just like we learned in one of the 4 pillars of OOP. Remember? So there is a lot of exciting stuff ahead, and so let's move on.